In this video, you will learn how to use the CLIA program called Stellar Spectra to classify the absorption spectrum of a star. Go to File, Log In, just click OK to start the program, and go to File, Run, and we will start by choosing Classify Spectra. And as soon as you do this, go ahead and open the Atlas of Standard Spectra. And we'll choose Main Sequence Stars. And this atlas is like a catalog that shows us the standard spectrum of certain classes of stars. It doesn't show us every subclass, but just a couple of subclasses for each class. It begins with the O class, and specifically the O5. This shows the spectrum of the O5 star, and I'll just go down and show B0, B6, A1, A5, F0, F5, G0, G6, K0, K5, M0, and M5. These are a little bit like fingerprints. Each absorption spectrum is unique for that class of star. So, by looking at the spectrum of a star, we can figure out what class it belongs to. In this window, it makes it easy to compare the spectrum of an unknown star to the standard spectra from our catalog. In the top pane, it's showing us the O5 spectrum, and in the bottom pane, it shows us the next spectrum, or next cooler spectrum, if you will, for the B0 class. If you click up and down with these buttons, you can cycle through the catalog and show those particular classes in the main window. I'll bring it back to the O star, and now I will load the spectrum of a star. Go to File, Unknown Spectrum, and Program List, and choose the first one. And it loads the spectrum into the middle pane. Now what we will do is we will compare the spectrum of this star to the spectrum from our catalog and decide what class this star belongs to. Now first, I'm going to show you what these peaks correspond to. Go to File and Spectral Line Table and move that window out of the way. When you double-click on a particular line, an absorption line, the program will tell you what element that line corresponds to. In this case, this line corresponds to hydrogen. Now you'll see that it says H1. The 1 means that it is not ionized. That is, it is a neutral hydrogen atom with all of its electrons. In particular, this line is called the H epsilon line. Now let's go look at one of these other ones. For example, this line here corresponds to the delta hydrogen line, or H delta line. Again, that is a line of neutral hydrogen. And this significant line here also corresponds to a neutral hydrogen line called H gamma. So you can see that for our unknown spectrum, we have significant, very, very strong hydrogen lines. And then we have a fairly strong, maybe we could say medium strong, calcium 2 line, and that's called the K line for calcium. Now the 2 in this case means that it is a singly ionized calcium atom. That means that the atom has lost 1 electron. How many electrons are lost for particular elements generally has to do with how hot the star is. And so often these, for particular atoms, they will lose electrons at certain high temperatures. Okay, well let's let's classify our unknown spectrum by comparing it to our catalog of spectra. In this case, we're going to look for a calcium 2 line and significant hydrogen lines. Okay, well let's just go down our catalog until we see a spectrum. Now this is getting close. We see a little bump here, and we get to see these 3 strong hydrogen lines, but it's not quite right. We need a much stronger calcium 2 line. So let's go down to the next one. Now that's getting awfully close. Look at that. We have the strong calcium here, all right, and the strong hydrogens. And let's go down one more. And, well, that looks pretty good, too. So we know it's probably either an A5 or an A1 or somewhere in the middle. Now, the software can help us decide what it is. If you click the Difference button, then what you see in the bottom pane is the difference between the top spectrum from our catalog and this spectrum for our unknown star. And so the difference actually subtracts one spectrum from the other. Now, the closer this is to 0 everywhere, the closer our spectrum matches that from the catalog. So, for example, this is awfully close to being an A1 star because this line, the difference is nearly 0 everywhere. Now, let's try the A5 star. As you can see, it's not as good a match because this difference is not quite 0 everywhere. The other one was much closer to 0. So we could be much more confident in saying it's an A1 star rather than an A5 star. Well, let's try a B6 star. Whoa, that's way off. Okay, so in fact it's definitely not a B6 star, which we could guess anyway because of the very, very low intensity calcium line. And so let's look at the A1. The A1's pretty good, so let's go ahead and call this an A1 star. So in this way, by comparing the spectrum of your star to spectra from a catalog, the standard spectra, you can determine what stellar class this star belongs to. It's a lot like fingerprinting. We are fingerprinting, if you will, the absorption spectrum for the star to determine what class it belongs to.